Today we did 425D as the warm-up, and that was related to the last lesson. So the question is to factor this expression. And we talked about last time that if a quadratic expression is in standard form, it looks like this. And we said, what do you do if it's missing a term? Well, we said, just put a 0 there. That's the same as nothing being there, right? So we did that, but we also wrote this in order. So if I wrote this in order, it would be 0x squared because the x squared term is what's missing. 40 is the constant. C is a constant. It's a number that doesn't have a variable next to it. And then minus 100. I'm going to use, instead of m, I'll just use x, and then plus 40. So if we wrote it in standard form, it would look like this. And then we would just follow the process that we've been using. And what's different about this one that we really haven't seen before is that these two numbers have a common factor. So I didn't do that with the warm-up, so I'll just do this one the way we've been doing them. X squared term and your constant in opposite corners. Multiply these two to get the top of your diamond, so that would be 0, x squared. Anything times 0 is 0. You could just put a 0 there. I tend to put 0x squared. And then the x term in the bottom. So I'm looking for two numbers that when I multiply them, I get 0x squared. When I add them, I get negative 100. So that would have to be 0x and negative 100. X. When I multiply these, I get 0x squared. When I add them, I get negative 100x. So 0x, negative 100x. And then we said, okay, what do you multiply to get 0x squared? One of these has to be 0. And I'm kind of looking at this term as I'm deciding what to put where. So I know it's going to be 0 times something, but I know that whatever this is, it's got to be a factor of not just 0x squared, it's also got to be a factor of negative 100. So I'm going to put 0x right here, and then negative 100x right here. Let's see if that works. No, I'm not going to put negative 100. And this is where it got a little tricky, because I'm going to just give this to you. We put negative 10x right here. Now you might be thinking, why did you pick negative 10? And I will show you. Okay, so when I multiply these two, I do get 0x squared. So I'm going to bring negative 10x over here. Negative 10x times positive 10 is negative 100x. And this is why I picked negative 10, because whatever this is, it's got to be a factor of 40. And this one wound up being a little bit harder than I had planned. Let's see, we've got 0x right here. So you might be saying 0x times what is 0x? And that's where it gets a little tricky, because you could put anything here. But this length and this width have to give you 40. So then this has to be a 4. So if this one's kind of confusing, don't stress. We wound up doing it, but then I wound up doing it an easier example in the lesson. So then this would factor into, for the length and width, 0x plus 10 times 4 minus 10x. And let me just make sure that that works. That's 0x squared. That is negative 100x, 0x, and that's 40. So that one, that's the answer for the warm-up. You can just type that in. And then we moved on to talk about factoring out the common factor. So factoring out the common factor is just going to make your life easier. You don't necessarily have to do it, but it does make it easier to do the diamond. So we looked at these four expressions and we said, Let's think about this. Actually, I think we did D as together as a class. So let's look at D, 3n squared minus, or 3n squared plus 9n plus 6. Okay, this was not the check-in, but it is the problem that we use to figure out how these work. These three numbers have a common factor of 3. So we are starting to see this now. So I'm going to divide by that common factor. I'm going to divide by 3, which is going to give me n squared plus 3n plus 6. 3 doesn't disappear. 3 is part of my answer. So I'm going to put equals 3. I do have a common factor of 3. And you're just going to keep that out in front of everything. And then you're going to do your area model with this expression. So n squared and 6. Multiply these, so 6n squared on top. This term goes on the bottom. And then you're looking for two numbers that when you multiply them, you get 6. When you add them, you get 3. So what can you multiply to get 6, but when you add it, you get, oh, that should be a 2. Whoopsie. Sorry. So this is 2n squared. This is a 2. 6 divided by 3 is 2. Okay, so what two numbers can we multiply to get 2n squared, but when we add it, we get 3? Well, there's only one set of numbers, right? 2n and n. So 2n times n is 2n squared. 2n plus n is 3n. So this is going to be 2n. This is going to be n. So nothing new here. The new part that we learned about is this common factor. And could you do the area and diamond with 3n squared, 9n, and 6? Yes, you could. It's just the numbers will be bigger and the diamond will be bigger. You'll have bigger number here, and that may or may not be difficult for you. But if it says to factor completely and you don't factor out this common factor, I can't give you full credit, for example, on a test. Okay, so then n times n is n squared, n times 1 is n times 2 is 2n, so this would factor into n plus 1 and n plus 2. Okay, so that was the example that we did together, and then the check-in was 435C. So this is asking you not to factor them. It's just asking you which of these two terms, which of these 4 expressions has more than one way to factor it. In other words, has a common factor. So what we discovered is that when you have that common factor, you can build the rectangle multiple ways. So for the check-in, you're just telling me which of these, 1, 2, 3, or 4, has a common factor in each of the terms. So you're looking at 12, 10, and 2. Is there a common factor? If there is, then put number 1. 5, 23, and 10. Is there a common? If there is, put number 2. 10, 25, 15. Is there a number that goes into 10, 25, and 15? 3, 7, 6. Is there a common factor for those 3 numbers? So that's all we did for the check-in. We said, and by the way, there's more than one answer. So which of these has a common factor? And then we tried to do one of these as an exit, but I really didn't give everyone enough time. So it's really just the warm-up and the check-in for this one.